Hi everyone, in this section what we'll be talking about is actually an extension off of our trig functions we talked about, our sine, cosine, and tangent. And what we're going to be doing, we're going to be applying sine, cosine, and tangent to the real world. Holy hot dog, right? I know. All right, but anyway, so we're going to be applying this through two different topics, one of which is called an angle of elevation. So if you've heard the word elevation, it means to rise up or to head upward, to elevate, to go up. Okay, so an angle of elevation is created by basically starting from a horizontal position and then heading upward. Okay, so the angle of elevation, it's the angle formed by a horizontal line in a line of sight to a point above the line. Okay, so like in this picture, we have this cute little cat. Okay, if the cat was looking straight, it would create this horizontal line. But then guess what? The cat sees the bird up here. So the cat will look up. So when the cat actually raises its eyes from the horizontal, it will create this angle of elevation right here. So it's kind of like when something is looking upward or when like a light is shining upward. Okay, so an angle of elevation is created by a horizontal line and then a line that is above the horizontal line. So usually again it happens when something is headed upward or someone is looking upward or some object is shining or being displayed upward. Okay, so it involves something heading in an upward position. So just keep that in mind. Angle of elevation is created by a horizontal line and a line of sight to a point above the line. Okay? Now, conversely to this is the angle of depression. So the opposite of angle of elevation is the angle formed by a horizontal line and a line of sight to a point below the line. So the angle of depression, okay, that is when you have an object that is created by a horizontal line and then a line that is below the horizontal line. So if you see here, you guys, we have this cute little bird. Okay, the bird was looking straight, but then the cat must have caught his attention and the bird looked down. So as the bird looks downward, it creates this angle of depression. Okay, depression, usually when we think about depression, it means you're sad, you're down. Okay, so depression in math means to head downward, which I know is a little weird, but anyway, so angle of depression is created by a horizontal line and then a point of sight that's below this line. So when the object or the person or the light or whatever it is heading in a downward motion. Okay, so that's kind of the difference between an angle of depression and an angle of elevation. Okay, so knowing that information, we're going to use sine, cosine, and tangent to help us either solve for these angles of depression and elevation, or we're going to use the angle of depression and elevation to help us solve for one of the sides of a right triangle using sine, cosine, and tangent, which is going to be pretty awesome. Okay, so in class, I should have given you this nifty piece of paper for you to work on these problems. Sorry, let me get this into focus. Come on, thing. Okay. Now, at the top of this paper, wow, that's like really unfocused. Sorry, guys. Let's see if I can get it better than that. That's really bad. Come on, thing. Oh, there we go. Okay, there we go. That's a lot better. Sorry about that, you guys. Anyway, so the part at the top, this is where you're going to be taking your notes. Okay, the problems will be on the front and the back of the paper that I gave you. Okay, well, let's look at example 1. And I wrote our little acronym at the top, SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So keep those in mind because what's going to happen, you guys, depending on what we're given in the problem, the angle of elevation or angle of depression will somehow form a right triangle. And guess what? We can use sine, cosine, and tangent to help us solve for the sides or the angles of a right triangle. So keep that in mind and let's get started. So anyways, one more thing, you guys, make sure you have out your handy dandy graphing calculator. And then if you prefer to use Desmos, make sure as you're watching the video that you have Desmos.com pulled up and you can kind of like minimize the video screen and minimize the Desmos.com screen and work on Desmos.com with me while I show you how to do it. So either way, again, by now you probably have decided which method you prefer to find the sides and angles of a right triangle. So you can either use your calculator or Desmos.com. But anyways, let's get started. So a kite is held by a taut string pegged to the ground. Okay, so I've kind of drawn this picture. We have this peg in the ground that's holding a string. Okay, now the word taut means it's a really tight string. Okay, just like when the kite's in the air, it's going to be pulling on the string. Okay, so the string is very tight. That's what that word means. But anyways, the string is 40 feet long. Okay, so on my picture, I've labeled the peg, the ground, also the string for the kite, I've labeled. Okay, and it told us that the string is 40 feet long. So guess what, you guys? It's always helpful to label your picture. So I'm going to label the picture. So the string is 40 feet long. Okay, so here I'm going to label the string of the kite to be 40 feet long. Okay, and makes a 33-degree angle with the ground. Okay, so if we're talking about the angle between the kite string and the ground, okay, which angle do you think I'm referring to in my triangle? Am I referring to the one on the ground, the right angle, or the one up near the kite? Well, I'm referring to the angle down here with the ground because this is the angle that's created by the string and the ground. Okay, so this is the 33-degree angle that's referred to in the problem. So, and makes a 33-degree angle with the ground. Okay, so this is the angle created by the ground and the string in the kite. Okay? Okay, supposing that the ground is level. Okay, so we're going to suppose that this ground is super level. Someone graded the ground down and made it flat. Okay, find the vertical distance from the ground to the kite. Okay, well, here's my pretty kite. If you want to label it, you can. I hope your picture looks better than mine because, like normal, I'm horrible at drawing, so I try my best. But anyway, so here's our kite. What we're solving for is the distance from the kite to the ground. So this dashed line I put in here because this is what we're solving for, and technically in your picture, this line right here doesn't really make sense in the picture. The picture is about the kite and the ground, but if I draw this nifty altitude down, that will give me the distance from the kite to the ground. And when you drop an altitude down, guess what? Altitudes form 90-degree angles with whatever they intersect. So this altitude is forming a 90-degree angle with the ground. And guess what, you guys? When I do that, I have a right triangle. And if I have a right triangle, I can use sine, cosine, and tangent. Look at that. Okay, so in all these problems, you should be able to create some sort of right triangle to help you solve using sine, cosine, and tangent. So keep that in mind. Okay, so we're trying to solve for, let's see here. We're trying to solve, find the vertical distance from the ground to the kite. So that's what we're solving for. So I want to know how far is the kite above the ground, or the vertical distance right here. This is what I'm solving for. Okay, so since I'm solving for this side, I'm going to label it X. Okay? Okay, so from here, we're just going to solve. Okay, so in my opinion, you guys, the hardest thing about these word problems is setting up the picture. After you got the picture, it just turns into a normal sine, cosine, and tangent problem. Okay, now, before we get started, I always like to know, am I dealing with an angle of elevation or depression? Guys, so this is the angle that we're given in the problem. Okay, we're not solving for the angle because they told us the angle, but I want to know, is this angle an angle, good golly, an angle of elevation or depression? Well, I spot in the problem a horizontal line and then a line that is above the horizontal line. Okay, so since the horizontal line went above to create this angle, this is an angle of elevation because the angle is heading in an upward motion. Okay, so we're dealing with an angle of elevation, so that's important to know. All right, and then from here, we can just use the picture to help us solve. Okay, so like normal, before I start solving, I like to know what parts of the right triangle have I either been given or am I trying to solve for. Okay, so I'm looking at the sides of the right triangle. So we're going to start from this nifty angle of 33 degrees. That'll be our start point with our angle. So side X, the opposite, adjacent, or hypotenuse of this lovely right triangle. Well, that's the side that is directly across from my 33-degree angle. So this will be, holy hot dog, you guys are brilliant. That would be the opposite side. Okay, and the 40 feet, this is the side directly across from my right angle. So what do you guys think? That is the hypotenuse. Which I don't know why I wrote it all out. Normally I would just write H, but it doesn't matter. Okay, so which angle has an opposite and a hypotenuse in it? Which trig function has opposite and hypotenuse? Sine, cosine, or tangent? Well, sine has the opposite and hypotenuse. So guess what? The trig function we'll be using is sine. So let's set this bad boy on up. So we have sine of the angle, which the angle I was given is 33 degrees. And this will equal the opposite over the hypotenuse. Alright, so the opposite side is the x. That is the side we're trying to solve for. So that's the x. Alright, and then the hypotenuse is the length of the kite string, which is 40. Alright, and then from here we just solve, you guys. So remember, when you're not solving for the angle, we're solving for a side length. When you're solving for the side length, this is when we're going to be cross multiplying. So I'm going to put my sine over 1, and I'm going to cross multiply. So let's get going, you guys. So 1 times x is x, and this will equal, let's go the other way. All right, so we have 40 sine of 33 degrees. Okay, and then from here, I just need to type this in. Now, don't forget, since we're dealing with word problems and real-world situations, our final answer, we need to express the units if we know the units, so keep that in mind. Okay, your answer is not complete without the units, so don't forget that. Okay, so I'm going to type this into my calculator real quickly. Don't forget, make sure your calculator is in degrees. So I'm going to go to mode. My degree is highlighted, which means I'm good to go. I'm going to hit clear. All right, so I'm going to type 40 sine of, sine, there we go. Sine of 33 degrees, and close that bad boy. And bam, my final answer, let's see here. It doesn't tell me to round, okay? It doesn't say like round to the nearest tenth or something. So honestly, it doesn't matter how you round. In this problem, we want to know the vertical distance. I don't know. I'll just round to the nearest tenth. Why not? It doesn't really say, so I can pretty much do whatever I want. So x is going to equal 21 point. Well, that 8 is going to bump 7 up to 0.8. Okay, and then from here, you guys, what are my units in the problem? I want to know a distance from the kite to the ground. So do you guys see a unit in distance in this problem that was already given to us? Well, we know the distance, or the length from the peg to the kite, is 40 feet. We know the length of the string is 40 feet. Okay, so my units are in feet. So the kite is currently 21.8 feet in the air. That is the vertical distance. So there you go. And again, if you like Desmos.com, again, all you do is just type it in. So I'm going to type 40 sine of 33. And if you guys see here, I got a different answer. That's because Miss Long did not check to see if she was in degrees. So remember, you go to the wrench, you go to the bottom. If you see, I'm in radians right now. So I need to click on degrees. And when I do that, now it will give me the right answer. So again, it's always really important to make sure you're in the correct unit. So on Desmos, make sure you're in degrees, not radians. Okay? All right. And again, you can also get to the trig functions if you go to the keyboard, click on functions, all right, and then the sine button is right here. So I could type 40 and then click this, sine of 33. And there you go, you guys. That's it on example 1.